Hi, my name is Dan. This video is one in a series that I'm doing on creating simulated multiplexers, which is part of digital electronics. Multiplexers are components which allow you to route or to choose one from several input numbers, binary numbers, and take it to an output. This is part of a much larger suite of videos that I'm doing, which develop a simple 4-bit CPU from the basic principles of logic gates all the way through to a working 4-bit CPU. So there's a roadmap of that and where I'm going in the description down below. Maybe you've dipped into this one in isolation. There are all sorts of explanations in earlier videos that if you don't know what's going on, you might need to know to understand the context of what I'm doing in this video. I'm using DigitalWorks software, which is simulation for digital electronics, partly because it's free, and there's a link to that software also in the description below. Partly because it's more visual than doing it with the actual components themselves, and it would be expensive to do it that way, or it costs some money anyway. So here we are, and in the last video I did the very basic simplest multiplexer, which is a two-way 1-bit multiplexer. It takes 1 bit of input signal from 2 different inputs and chooses one of them and sends it to an output. And what we're going to do in this video is we're going to take that macro component and we're going to expand this up to a two-way 4-bit multiplexer. So our 2 inputs will both be 4-bit inputs. And so it is fairly clear where we need to go with this. We're going to need 4 copies of our two-way 1-bit macro, so I'm just dragging that in. And then we're going to need to do some wiring up. So the control wire is going to come in. We're going to turn this whole thing into a macro as well. So we're going to have various tags to use for inputs and outputs. 1, 2, 3, 4. Is it best doing it that way? Actually, what I'm going to do is I'm going to make the tags much closer to the chips themselves. So let's talk about what I'm going to do in terms of the wiring. I'm going to attach a tag to each input and output for these, and they will be then on the template organized in such a way that we kind of understand them better. It would be possible at this stage to do, as I kind of started to do, here's our input 0, and to do the wiring down from there. But actually, it makes sense to just put the tags fairly close to the components and to sort out what numbers they're part of when we do it in the template. So mostly what I'm about to do is a load of tags, a load of little wires, but then this control wire is going to be connected to all the controls of these 4. And the reason why I've done a description of that is because this is going to take a few minutes, so I'm going to play some music and speed up the process in the video. Right, so that's wired up. I'm going to add some annotations on here. So I'm going to name these bits. So that's bit 3. Just doing Control C, Control V there to replicate that. Oh, what have I just done? Name macro. No, thank you. Edit annotation. Bit 2. Bit 1. Bit 0. Maybe that text is a bit small, but sorry about that. Right, into the template editor. And previously we've had a two-way 1-bit mutex. So, sorry, not. I need to be careful what I say. Multiplexer, not mutex. I see the MUX and my mind goes mutex, and that's a completely different thing to do with threaded programming. So two-way 4-bit. We're going to need 4 of these on the output. So I'm going to create an extra one. And I'm being sneaky. I'm going to pull one down from there. Come on. Another one down from there. And now that's 4 in an array. I'm going to copy and paste. And I'm going to move one to there. And one to there. And in my annotations here, I'm going to just indicate which way round the binary number is, the input. So it's 3 means the most significant bit, 0 is the least significant bit. This is a fairly normal way of annotating this sort of thing. 3 to 0. And we don't need extra pins on the control, because that's still just a single line, because it's a two-way multiplexer. So I'm going to close that. I'm going to do the wiring up now of these tags to the to the pins on the template editor. There's a few of these to go. So again, I'm going to play some music and speed up. But before I do that, I'm going to say that you need to put some, careful thought into making sure that you do connect the right pins to the right tags here. So that should be all wired up now, and we're just going to save this. So before we had an MUX two-way 1-bit, and this is going to be MUX two-way 4-bit. Save that, and again, as before, I'm going to create a new circuit. In order to test this, I'm wondering what happened to that, because it has not appeared here in my macros. So let's I'm a little bit curious about that. That's got bit 3. What's bit 3? Please bear with me. I'm just going to go up 1 and then down 1, and that still looks different. What happens if I pull that in? I wonder if that is the thing. I don't know why now. Do you remember at some point by accident I hit name macro? So what I'm going to do is I'm going to see if I can get into this templates. Right, I'm going to have to go backwards. I have just found a new feature in DigitalWorks. I'm going to have to open that. It's just named differently from the files. So don't change current circuit. Open that, and in the template editor, highlight that text. Edit annotation. Cancel. Where was it? Was it in here? I'm going to annotate MUX 2Y 4-bit and name macro. And then we're going to save. Has that actually worked? I don't know. My macros. Yes, it's changed the name of it. So we're going to make a new circuit, get rid of that, and put that in. So apologies about that. That's something I didn't know how that works. And we're going to wire up 2 4-bit inputs and 1 4-bit output. Do you want to speed up again and give you more of the music? Go on then. Right, there we go, all wired up and ready to roll. And let's get this simulating and see what happens. So at the moment, we've got our control is 0, so the output should mimic whatever is coming in on this input. And as we change these numbers, we can see that it's happening as we expected. And if we put control to high, it then should be mimicking this side instead. That is doing exactly as expected. So I've got a proof of concept. So that is a 4-bit 2-way multiplexer. And that's it from me for now.